Hi my friends, welcome to another video clip of MrLopezClasses.com. In this video clip, I am going to explain the procedure to reverse rotation in AC motors and DC motors. This video clip is part of the chapter 13 of your Marine Electrical Handbook. In the chapter 13, I talk about AC motors, DC motors, reversible motors AC and DC, and transformers, step up, step down, and isolator transformers. The chapter 13 is divided in 3 episodes, and this video clip is part of those 3 episodes. If you are interested in the episodes, enter in my web page, select the button Buy My Books, Buy My Videos. When you select the click on Buy My Videos, you have the options to see all the chapters. And then in each chapter, you can buy an individual episode, or the chapter, or the book. In this moment, I have specials for yours. Write to me to info@MrLopezClasses.com, and I have special prices for you. I have a special packet included the book and all the videos for a ridiculous price. Write to me to info@MrLopezClasses.com, and we can share our experience. I hope that you enjoy these videos. I hope that you enjoy these episodes. Alright, right now we are going to talk about AC motor reversible motors and DC motors reversible motors. I hope you enjoy this video clip. Now I am going to explain reversible motors, DC motors or AC motors. All the motors are reversible? Depends. The DC motors are reversible. In small DC motors, what is the meaning of small DC motors? Motors that the consumption is less than 10 amps. Small motors like this one. This is a blower, DC blower. The consumption of this one on the plate is 4 amps. Okay, this is considered a small motor, less than 10 amps. If I connect the polarity positive and negative in this direction, the motor spins clockwise. If I switch the polarity, the motor spins counterclock. Yeah, it's simple. How can I do that? You can do that with a simple switch, toggle switch, double input, double output, if you connect in this way. This is a toggle switch, double. The input is in the middle, one output double and other output double. Yeah, this is a double toggle switch. This is the back of the switch, double. Okay, this is the procedure to reverse rotation in a small DC motor using a toggle switch, double input, double output. The procedure is like this. In the middle, in the input, you connect the positive and the negative of the battery. And in the output, this is the motor, this is the blower, the positive and the negative, and you cross this position here and this position here. When I select the top position, the motor spins clockwise. When I select the bottom position, the motor works backward. You can rotate, you can change the rotation with a simple switch, double, connected in this way for small motors with less than 10 amps. For motors when the consumption is more than 10 amps, I am going to explain right now the procedure. Okay, the DC motors, if the DC motor is considered low current, less than 10 amps, like blowers, fans, small electrical and electronic motors, you can switch the rotation only when you switch the polarity. You can switch the polarity with the double input, double output toggle switch. Okay, if the motor is a high current motor, for example, the motor of the windlass, bow thruster, hydraulic units, those motors are considered high current because those motors suction more than 10 amps, 20 amps, 30 amps, 60 amps, depending on the motor. Those motors, the properly way to change the rotation is with a solenoid control box or with a couple of relays. I am going to explain right now the procedure to install the solenoid control box in heavy-duty DC motors in order to reverse the rotation. In AC motors, can you rotate can you switch the rotation in a single-phase motor? It's not common. If the motor originally is a split phase with a capacitor, you can switch the rotation of the motor if you switch the polarity on the capacitor if the winding is a split phase. Not all the single-phase motor AC motors are reversibles. Only the single-phase motors with a split phase and capacitor, you can switch the rotation. What about the double-phase and three-phase motor? The majority of the double and three-phase motor are reversible. In a three-phase motor, you can reverse the rotation only when you switch two phases. What phase you need switch? A, B, or C? You can switch A with B, or B with C, or A with C, doesn't matter. You need switch two phases and immediately the rotation changes. I am going to explain right now the procedure to do that easily. Basically, you need use contactors. When you use contactors, you can switch the rotation. Contactors are commonly used in millions of applications. I am going to explain right now. Okay, I am going to explain right now the procedure to reverse rotation in DC motors using solenoid control box and relays. I have a board that I prepared for yours in order to explain the procedure to change rotation in DC motors. This is a typical DC motor with a reversible rotation. If you check the motor have the negative in the middle and two positives. Depending if the positive current is entering here, the motor rotates clockwise. If the positive current is entering here, the motor rotates counterclock. Depending where is entering the positive, the motor rotates in one or other. Internally, it's because this motor have a double winding. Of course, this is a heavy motor. This particular motor is for 100 amps. 100 amps is a lot of amps. Okay, we are going to use, in order to reverse the rotation, this equipment. This equipment is a solenoid control box. This is the solenoid control box. The solenoid control box have three big terminals. Those three big terminals are three positives. This is the positive in the middle coming in. That power is coming from the battery, from the switch selector. And this is positive coming in, and this is positive coming out, and positive coming out. This is positive coming out for clockwise rotation, and this is positive coming out for counterclock rotation. And I need send the signal to activate this position, or I need send the signal to activate the other position. Okay, the signals for clockwise or counterclock are coming from this toggle switch single. The input is in the middle. The input, the positive, is coming from the battery, enter in the middle, and I have one possibility: rotate clockwise or rotate counterclock. The only that I need is bring the signal here or bring the signal here in order to send the power over there or send the power over there. In order to do that switch of rotation, I use the solenoid control box. Where I found this type of equipment installed in my boat, this is, for example, the windlass. You found it exactly the same for a bow thruster. You found it exactly the same for hydraulic central units, for hydraulic actuators, up and down. It's a reversible DC motor controlled by a solenoid control box and the switches. This switch This one could be the joystick of the bow thruster, or this one could be the foot pedals for the anchor. Yeah, I replace for those switches, but you can replace those switches for momentary switches, up and down, or for a joystick for bow thruster. The procedure is exactly the same. How is the diagnosis to check this unit? The diagnosis is simple. Now we are going to do the diagnosis to verify when I have a problem with a DC reversible motor heavy current. For example, the customer complained that suppose that this is the motor for the anchor, for the windlass. The customer complained that the anchor is going down, but not up. The anchor is going down, but in the other position, nothing. Okay, unit verify. The first step is go where the motor is located and verify if the motor is in good condition. Doesn't matter if the solenoid control box or the switch is good, you need verify if the motor is in good condition. The proper way to do that is connect a big cable from the positive of the battery, and goes directly into the right side and left side movement. Okay, this position is good, and now, okay, my motor is in good condition. Oh, let me explain if my solenoid control box in the output is okay. Okay, the solenoid control box in the output is good. Let me check if the solenoid, when the solenoid receives, the solenoid control box receives the signal, change the position. Okay. Alright, my solenoid control box is good. When I bring the signal from here or bring the signal from here, the solenoid control box said, probably if this is okay and the customer complained that only goes down, the motor is okay and the solenoid control box is okay, what is the problem? The problem is here in the switch. I need verify with this, with the touch probe, if my switch is good. Okay, I have power in the input. Yes, I have power in the input. I need verify down this position. Okay, good. I need verify the second one. Nothing, no power here. My switch is damaged. I need to replace the switch. That's the procedure to verify if the problem is the switch or if the problem is the solenoid control box. A very common problem is that the solenoid control box is damaged. Where is located the solenoid control box normally? The solenoid control box is located pretty close to the motor. If this is a windlass and this is the solenoid control box of the windlass, this element is located in the locker where the windlass compartment is located. In other words, the enemy of those equipment of the solenoid control box is water. You remember that when the anchor is coming in, the chain is coming with water and splash water when the chain enter in the compartment. That water splash and corrode the solenoid control box. The majority of the solenoid control box after 2 years are fully corroded and should be replaced. Those solenoid control box are expensive elements. It's more than $300 depending on the quality. In some cases you are in the middle of the ocean and you need to solve the problem for the windlass and you don't have an extra solenoid control box. You can replace the solenoid control box for a simple situation with a couple of relays. Those are automotive relays, $12 each one. You can replace this one for a couple of relays. Yes, you connect two relays in series parallel in order to do the same function of this. We are going to refresh the function of the solenoid control box. The solenoid control box have one input in the middle and two outputs for big current. And exactly the same for the signal. The signal for one direction, the signal for the other direction, coming from the remote switch and the ground in the middle, of course. Okay, I am going to replace the solenoid control box for a couple of relays. And this is the procedure to connect the relays. I enter with the power coming from the battery in the middle. Exactly the same like this. The power enter in the middle. And the output of this relay go for clockwise rotation. And the output of this relay goes for counterclock rotation. The relays, the middle ones, should be connected to the ground bus bar. And the externals, one for clockwise and other one for counterclock. This is the switch to operate those relays and work exactly the same like the solenoid control box. You replace that expensive equipment with $20 for this situation, and this is a permanent good solution. You can replace this for this forever. You don't have any problem, you don't have any inconvenience. The only that you need verify is the capacity in amps of the relays. What is the capacity of the motor? Okay, depending on the capacity of the motor in amps, you need to replace the capacity of the relays, and you do the installation. In this particular case, I put both of them. I connect the switch selector. I have one output for one and the output number 2 for the other situation. This is the typical reversible DC motors used in millions of applications in medium and big boats. DC reversible motor for windlass, for bow thruster, steam thruster, for hydraulic systems, for actuators, pasarellas. That's the situation, and this is the procedure to do the installation and the troubleshoot. The troubleshoot in this configuration is exactly the same. Suppose that the windlass is going down, the yellow one, but never up. You need to verify once again that the motor is good. How you verify if the motor is okay? With a big cable, you bring positive directly from the battery and you check that the motor is spinning in both directions. And now you bring the power directly from the positive of the battery, and you check if the relays are okay. The output of the relays are okay. One direction and the other one. Okay. And now I am going to verify if the relay is working when the relay receives the signal. Okay, receive the signal. Okay, receive the signal. Okay, the relays are okay. Probably my problem is on the switch. It's exactly the same. You need one cable, big cable with high capacity. You need the test probe. You don't need a voltmeter. You don't need a multimeter. The only that you need is those equipment. Thank you. What is the procedure to reverse rotation in a 3-phase motor? Basically, you need to switch 2 phases. Suppose that you have 3 phases, A, B, and C. You can switch A with B, or B with C, or A with C. Doesn't matter. You switch 2 phases, and immediately the motor reverses the rotation. How can you do that during the operation of the motor? It's simple. You can use contactors. The only way to reverse rotation in a 3-phase AC induction motors is with contactors. And right now, I am going to explain what is the meaning of contactors. 3-phase reverse rotation. The properly way to reverse rotation in a 3-phase motor is by means of contactors. The contactor is basically a breaker, the 3-phase breakers, with a couple of inputs for the signal. The signal should be AC or DC. For example, this is not properly a contactor, but it's exactly the same. It's a breaker, a 3-phase breaker, with 2 inputs on the side for the signal. What is the function of the signal? Open and close the breaker. Open and close the breaker. Where is coming that signal? It's a remote signal. That signal, once again, is coming from the flybridge, from the pilot helm, and that signal could be DC signal or AC signal, low current signals. A contactor is a remotely activated breaker. The remote activation could be a low current AC or DC signal. The signal enter here, AC or DC, and those are the 3 phases. And the rest is a typical breaker. How can we install those contactors how is the wiring to connect a three-phase motor with the contactors in order to reverse the rotation. I have an schematic that I prepared for use. In this schematic, if you check the schematic, I have the main breaker. That's the main breaker that you have in your AC panel. And this is the AC power. The AC power is coming from the source of the power, three phases. And this is the output of the main breaker. The output of the main breaker enter in a couple of contactors. I have two contactors here, three inputs, three outputs, three inputs, three outputs. Okay, the first contactor is for clockwise rotation, and the second contactor probably for counterclock. Okay, the first contactor have three inputs, black, red, and blue. The black one, the first position of the first contactor is connected with the first position of the second contactor. Black with black in first position. The second one, the red one, in the first contactor goes into the third one in the second contactor. And the third one in the first contactor go into the second one in the second contactor. That's the switch. I am going to switch the phase 2 and the phase 3 in the second contactor. Okay, and the output is exactly the same. 1 with 1, 2 with 2, and 3 with 3. And the phase number 1 is the black one. The phase number 2 should be the red one. And the phase number 3 is the blue one. Those are the phases that enter in the motor in order to reverse the rotation. And the signals. In this particular case, those contactors are DC remotely activated. Okay, the activation is DC. I have a couple of push buttons, normally open contactor, push buttons. And I am going to activate those contactors with a DC signal coming in DC signal. This is the positive bus bar of my DC panel, and that's the positive bus bar receives the power from the batteries. Okay, the positive enter in the middle in between both contactors, and from the output of the second contactor I activate the contactor number 2. And from the output of the second push buttons, I activate the first contactor. When I press this button, I activate the clockwise contactor. When I press the second push buttons, I activate the counterclock contactor. This is the procedure to use contactors and push buttons. You can use normally open or normally closed buttons. It's simple with the normally open momentary push buttons. When I press this one, the motor rotates in one direction. When I press the second one, the motor rotates in the other direction. This is perfect for windlass. This is perfect for bow thrusters. And yes, I can replace those push buttons for a joystick. In one position, I send the signal for this contactor. In the other position, I send the signal for the other contactor. This is exactly the procedure to connect contactors in order to reverse rotation in AC motors, three-phase motors. Remember, the procedure to reverse rotation in DC motors, high current motors, is with a solenoid control box or with a couple of relays that I explained in the previous episode.